Now, I'll get into whether or not NASA knew this at the time or not, but that little piece of foam is going to come off and it's going to hit the wing. The piece of foam is about 20 inches by 12 inches by about 8 inches. It weighs 1.67 pounds, and when it strikes the wing, it will have a relative velocity. See the speed up there, the speed 1,587 miles an hour, 1,588 miles an hour. But the foam will have a relative velocity of about 525 miles an hour. Essentially, the foam is slowing down and the orbiter is speeding up. That's essentially what happened. It had about 525 miles an hour of relative velocity, and NASA was absolutely convinced that a strike like that could not possibly damage the orbiter. What happened is that NASA succumbed to the gambler's dilemma. Foam comes off the orbiter, comes off of that external tank on every single launch. And every single launch, the orbiter is damaged by foam striking it. And every single launch, NASA got away with it. And so what they did was, they then said, well, obviously foam is no longer a hazard. When they started, foam was a level 1, crit 1 hazard. Thou shalt not touch the orbiter, because the orbiter is covered with a very delicate thermal protection system, which it has to have intact in order to get back into the Earth's atmosphere. Well, after getting away with damaging the skin over and over and over again, NASA then fell into the gambler's dilemma. If you are going to bet on roulette, and you decide that you're only going to bet on either the red or the black, because you got a 50-50 chance of winning, but before you place your bet, you watch 3 spins of the roulette wheel, and the little P lands on 3 reds in a row. Well, then you know that you're going to bet on black, because the next one's got to be black, right? Wrong. It's still 50-50. What happened in the past has got nothing to do with what happens to the next roll of the P. NASA forgot that. They assumed that since they've been getting away with it, and the shuttle hasn't been damaged by all this strike, that therefore it must not be any danger in the future. The orbiter's up and orbiting right now. It's on day 2 or day 3. The astronauts are up there doing their thing. So now here you are on the ground, you're a bunch of engineers, and the question is the orbiter okay? So now a bunch of people get together to do an assessment. And they reach their conclusion that they can't tell. And what they want is, they want pictures of the orbiter. You've probably read about this, the famous email writing from the engineers at Langley who wanted pictures. The manager said, no, foam can't hurt an orbiter. That's because we are experts at roulette, and we know that we've gotten away with it in the past, and the odds are we're going to get away with it this time. But if you can prove that there's a problem, we will get pictures. Wait a minute. The engineers just said they needed the pictures to prove there was a problem. So here is the principle that's missing from your book. NASA put people on the moon by following the principle of you must prove it's safe. If you are the propulsion guy, or you are the guidance guy, or you are the thermal protection system lady, or you are the whatever it is, you must prove your systems work. Now, what did you hear when the managers responded to the engineers saying we need pictures? You must prove it's unsafe before I do anything. They have reversed the equation from you must prove it's safe to now you must prove it's unsafe or I won't take any management action. What kind of an organization is that?